Okay, thanks for tuning in. This is a video to help give you some support for the questions 1 through 7, the exercise questions on the mole concept activity. So here we go. I'm going to, just so you know, I'm going to kind of show you how to set up and how to think about problems 1, 2, 3, and 5. Okay, so problems 4, 6, and 7, I'm going to leave that to you to try to wrestle with those tonight. But if you need the help, I'll kind of show you how to work through 1, 2, 3, and 5. Okay, so question number 1: what is the mass of 1.00 mole of copper? Okay, so you're definitely going to need your periodic table and a calculator. So make sure you've got that handy. So if you want to determine the mass of 1 mole of copper, all you got to do is go to your periodic table and locate copper. Okay, so copper is right here. It's on the first row of the transition metals, which are in the middle of the periodic table. And if you look carefully at the atomic weight of copper, it's 63.546. In our class, we've agreed that we're going to round these atomic weights to 2 decimal places. Okay, so this would be 63.55. Now, what that means is that one atom of copper has a mass of 63.55 AMU, atomic mass units. But if we want to know how much 1 mole of copper weighs, then you can show that it's just the same number as the atomic weight, but it's in grams. So if you measured 63.55 grams of copper, you could be assured that you've got 1 mole of copper atoms. And that's, and don't forget, 1 mole is 6.02 times 10 to the 23rd. Okay, so that's the answer for number 1, 63.55 grams. There you go. All right, number 2. What is the mass of 1.00 mole of sodium fluoride? Okay, so sodium fluoride, again, we're going to have to look up the atomic weights of both sodium and fluorine and then add them together, because this is a compound. And you guys know compounds are made of more than one element. So we turn back to the periodic table, all right? And let's see, where's sodium? Well, sodium is one of the alkali metals, which we're going to learn about in the next unit. And so that's over here. You can see it has an atomic weight of 22.99 AMU. Yeah, and then fluorine is way over here. And that some periodic tables are going to say 18.998, and because we're rounding to 2 decimal places, fluorine for us is always going to be 19.00. Okay, and since we're talking about the mass of a mole, then we will attach the units of grams to each of these, and so 1 mole of sodium fluoride has a mass of 22.99 grams, which is the sodium. That's the molar mass of sodium, plus 19.00 grams, which is the molar mass of fluorine. And when you add those two together, you get 41.99 grams. And that's all there is to it for problem number 2. Number 3, consider a 1.00 carat diamond, which, as we talked about at the beginning of the year, the diamond is one of the allotropes of carbon. It's pure carbon. And a carat, when you talk about diamonds, the number of carats is essentially like how big it is. So the more carats, the bigger it is. So you're talking about pure carbon, and it has a mass of 0.200 grams. First, how many carbon atoms are present in this diamond? And we can figure that out using the mole concept. And then the second question they're asking is, give your answer in terms of a number and as a number of moles of carbon. So the 2 questions are, if you've got 2/10 of a gram of diamond, how many carbon atoms are in that sample, and how many moles are in that sample. That's what it boils down to. Okay, so yeah, so these are the two things, and in order to determine, let's start with, I want to start with the moles. That's probably the easier place to start. And so you know that 1 mole of carbon atoms has a mass of 12.01 grams of carbon. So that's, I've demonstrated that the first 2 times, how you find molar masses from the periodic table. So, just look at your periodic table, and when you see carbon, you'll see the atomic weight is 12.01 grams. If you have that many grams of carbon, you have 1 mole of carbon. Now, in order to figure out how many carbon atoms you've got altogether, you've got to know the equivalence between moles and how many objects. Okay, so we know that 1 mole is equal to this many things. Okay, so let's start by solving for the number of moles. All right, let me see if my pen is working here. There we go. Okay, so we start with the given. All right, so this is the amount of the carbon. Okay, and so we're going to start with that. So 0.200 grams of carbon, and we want to convert that many grams of carbon to moles, and this is the equivalence that we need, right? That's going to take us from grams of carbon to moles, and so we're just going to set up a conversion factor. All right, and because we want moles, we're going to put the 1 mole on top. Okay, 1 mole of carbon over 12.01 grams of carbon. Okay, so you see how I use this first equivalence to construct my conversion factor. And when you do that, let's see what we get. So take your calculator and take 0.200 grams and divide it by 12.01. Okay, and you will get 0.1. Oh, sorry, my bad. 0.016. And then I guess I'm going to round that to 7, and that's moles of carbon. All right, and it's moles of carbon because look, my grams cancel, and moles is the unit that survives. Okay, and so there you go. That's how many moles of carbon you've got. Now let's address the first question, where it's asking about how many carbon atoms. Okay, so for this one, we're going to use, let me just kind of clean this up a little bit. We're going to use the second equivalence. 1 mole equals that many objects. So I know how many moles that I have, right? So I figured that out. And now here I'm going to use the equivalence between moles and the number of objects. And the objects in this case are atoms. Okay, so I start with my given, which is this. Okay, so 0.0167 moles of carbon, and I'm going to apply a conversion factor, and I want objects or atoms on the top, so that's 6.022 times 10 to the 23rd. Now I'm not going to write objects. Okay, this applies. This depends on what kind of thing we're talking about. This could apply to atoms, which is what we're doing in our case, but it could also apply to molecules. Okay, so I'm going to put atoms here, and I know that this is equivalent to 1 mole, so I'm going to put 1 mole over here, and now my moles cancel, and when I take 0.0167 and multiply it by 6.022 times 10 to the 23rd, I get 1.01 times 10 to the 22nd carbon atoms. Oh, what do you know? Okay. All right, so there you go. So that's how you approach number 3. Okay. All right, and then finally, I'm going to skip to number 5. It says ethanol has a molecular formula of this. What is the mass of 1 mole, 1.00 moles of ethanol? And what is the average mass of 1 molecule? Okay, so we want to know the mass of 1 mole of ethanol and then the average mass. Okay, so let's see. So if we want to know the molar mass, so let's take a look at this expression. These words, mass of 1.00 moles. So this is what we call the molar mass, right? So the molar mass is simply the mass of 1 mole of a substance. And to get this, we're going to have to take the formula, and we're going to look up the atomic weight of each element. So we've got carbon, we've got hydrogen, and we've got oxygen. Those are the 3 elements that are involved. And then we have to multiply the atomic weights by the number of, the corresponding number of atoms of each element. So let's start with carbon. All right, so we got carbon, and how many carbons do you see in this formula? Okay, so if you found 2, you are correct. So that's going to be 2 times the atomic weight of carbon, which, as we saw previously, is 12.01 grams, and so that's going to be 24.02 grams. Then we have hydrogens. Let's see, how many hydrogens do we have? So we have 3 here, we have 2 here, and 1 there. So that's 3 plus 2 plus 1 is 6. Okay, hydrogen. So that's 6 times 1.01 grams, which is equal to 6.06 grams. And then finally, we have 1 oxygen, right? So oxygen, 1 times 16.00 grams is 16.00 grams. And when you add those 3 totals up, you get 46.08 grams. And that is the molar mass. Okay, so we've answered the first question. What is the mass of 1.000 moles of ethanol? This right here. That's how many grams. Second, what is the average mass of 1 molecule of ethanol? Well, okay, so first of all, they're using the word average, and that's just by taking the atomic weights off of the periodic table for each of the elements. We are using the average atomic masses for these, so that's all taken care of implicitly. But they want to know what is the mass of 1 molecule. Okay, so what we do here is this is the mass for 1 mole. Okay, so I'm going to rewrite this. This will be our given. So this is grams per mole. Okay, and we're going to use the relationship. We know that 1 mole is equal to 6.022 times 10 to the 23rd objects, right? And so we can, we're talking about molecules in this case. Sorry about that. And so this is going to be molecules of ethanol. And so I'm going to put 1 mole on top and 6.022 times 10 to the 23rd molecules. Okay, and so the moles cancel, and so what we'll get is we're going to get grams on top and molecules on the bottom. So that's going to be our those will be our final units. So now all you got to do is take 46.08, divide by 6.022 times 10 to the 23rd, and you should get 7, pardon my writing, 7.65 times 10 to the minus 23, and that's grams per molecule. Okay. All right. So, and that's a really, really small number. So 1 molecule of ethanol doesn't weigh very much, that's for sure. Okay, so that's all for now, and I wish you the best of luck with the other problems, and I hope this is helpful. All right, so I'll see you soon.